In this video, we will continue our discussion about dimensional analysis. The person that you see here is Edgar Buckingham. Buckingham's pi theorem is named in his honor. The basis for the application of dimensional analysis is found in Buckingham's pi theorem. Please pause the video and read and understand this very important theorem. The key point here is that similitude between a model and a prototype is achieved by equating pi terms. Let's dive right in to showing how a set of pi terms could be determined. Let's go back to the simple bus hatch. How do we determine a set of pi terms to study this problem experimentally? First we ask, what is drag a function of? Well, let's assume that the drag force on the hatch is a function of width, height, fluid viscosity, density, and velocity. Now we ask, what are the dimensions of each variable? Drag is a force in newtons, which means it has dimensions of mass times length divided by time squared. Width and height have dimensions of length, while viscosity has dimensions of mass divided by length times time. Density has dimensions of mass divided by volume, which is length cubed. Velocity has dimensions of length divided by time. Thus far, we have 6 dimensional variables: drag, width, height, fluid viscosity, fluid density, and fluid velocity. Therefore, let's say n equals 6. We see from the list on this slide that there are 3 fundamental dimensions: mass, length, and time. So, k is equal to 3. The number of pi terms needed to study this problem experimentally is determined by subtracting the number of dimensional variables by the number of fundamental dimensions. So n minus k is 3. Therefore, we need 3 pi terms. The third step is to select 3 repeating variables that we can use in our pi terms. It's not a good idea to choose width, height, and velocity because they have very similar dimensions. It's a better idea to choose width, density, and velocity because they have different dimensions. So, now let's determine the first dimensionless pi term. The first pi term will take the dependent variable d, and you will now multiply d by the repeating variables that were chosen. So now let's make this dimensionless. Notice that a, b, and c occur as exponents for width, velocity, and density, respectively. The goal is to determine the values of a, b, and c that make this pi term dimensionless. To do this, we express the variables in terms of their dimensions. To have a dimensionless term, the exponents of the repeating variables must sum to 0. To see what I mean, let's focus on mass m. Here we see that we have a mass m on the left with an exponent of 1, and a mass on the right with an exponent of c. The exponents for m must sum to 0, and it is shown here. Now let's focus on the second repeating variable, L. The sum of its exponents is shown here. Doing the same for t, we get this. Now that we have these 3 equations, we need to determine values for a, b, and c that make all 3 equations true. Thus, c would have to be -1, and b would have to be -2. Plugging these into the middle equation, and we see that a will have to be -2. We plug these values for a, b, and c back into the first pi term, and we see that it is non-dimensional if drag is divided by width squared times velocity squared times density. This is our first dimensionless term. We need 2 more. Let's repeat the procedure for the next non-repeating variable h to get the second pi term. Again, we multiply the non-repeating variable h with the repeating variables w, v, and rho with exponents a, b, and c, respectively. we again express the variables in terms of their dimensions. Let's again focus on mass m. Here we see that we have a mass m on the right with an exponent of c, but that's it. Therefore, c would have to equal 0. Now let's take a look at L. This is a little more challenging, since L has exponents of 1, a, b, and negative 3c. Let's come back to this later. Let's take a look at t. Here we see that t only has an exponent of negative b. Therefore, b is equal to 0. Plugging in b and c into the middle equation for L results in a equaling negative 1. Here we see that the second dimensionless term is just height over width. Now is a good time for a quiz. For this quiz, you will be given the task of finding the third pi term. Please pause the video now and work out this problem. Then unpause the video to check your solution, which will be one of the choices on the right. The correct answer is C. The first step would be to express the viscosity in terms of the repeating variables, which in this case is mass divided by the product of length and time. We see that A, B, and C would each have to equal negative 1, which makes the third pi term viscosity divided by the product of width, flow velocity, and density. Now that we know all three pi terms, we see that dimensional analysis enables us to take drag, which is a function of width, height, viscosity, density, and velocity, and reduce it to three dimensionless pi terms, where pi sub 1 is a function of pi sub 2 and pi sub 3. In summary, similitude between a model and a prototype is achieved by equating pi terms. Buckingham's pi theorem is again summarized in this slide. We will continue our discussion on models and pi terms in the next video.